Hey folks, you're listening to the Java Easily podcast, episode number 15.
Java Easy. News, tutorials, tips. Everything you need to know as a beginner Java developer.
Hey again, welcome back to the podcast. So in the last two episodes, we've been taking a look at why IDEs are a phenomenal tool for Java development. In this episode, we're going to see the third aspect to them, which makes us super productive, so more of that in a second. Just before we get into this though, we give a quick shout out to the Java Beginner Starter Kit. So if you haven't downloaded this yet, and you're completely new to Java, then go over to our website, that's javaeasily.com, and go grab the Java Beginner Starter Kit from there. It's completely free, and it gets you up and running with Java in the quickest way possible. Anyway, let's jump into the episode now. So, the first thing we spoke about in this series was how IDEs make coding easier for you, with everything from syntax highlighting, code generation, right through to refactoring. The second thing we highlighted was how the IDE gives you a super easy developer experience by doing all the heavy lifting for you process-wise, giving you a really slick and easy editing and run lifecycle. Now, if we get even more advanced, and as you get more advanced as a programmer, we go to step 3, or item 3 if you like, and this is really the fact that an IDE is an absolute powerhouse for analysis. So the way an IDE enables you to analyze code, and this is not running through code or stepping through like we've seen before with the debugger we just spoke about. This is actually doing structural analysis of how the code is laid out, giving you insights into how it's designed, that kind of thing. An IDE gives you tons of tools for this straight out of the box. So for example, and a quick warning here, this is more advanced stuff, obviously. This episode, if you're completely new to Java, it might be a little bit over your head. It probably will be most of it over your head, but it will hopefully give you a taste of, what you can expect to find in an IDE, and also give you the comfort, I guess, the fact that, when you get to be more experienced, although concepts might become trickier, the nice part of that is the fact that you have an IDE, you have this tool with you that's going to support you every single step of the way. So it's not like it just gives you a bit of help in the beginning as a beginner, and then when you get into really advanced stuff, you're completely lost. It doesn't give you any support. Not at all. So that's kind of useful as well, I guess. But anyway, back to this notion of a powerhouse for analysis. So it gives you the ability to be able to comprehend the code base at different levels and through different perspectives. So for example, when I'm looking at a piece of code for the first time, either it's an existing code base that I've been working on, but it's an area that I haven't quite touched on yet. In other words, I haven't encountered that particular area of the system, that kind of thing. So what I'll do is I'll typically use the structural analysis or the different analysis tools inside the IDE to enable me to comprehend that code better. These are some things I typically do. I'll look at call hierarchies. So a call hierarchy, just like when you're stepping through code in a debugger, as you step into a method, you'll see the stack frames on the left-hand side of the debugger. Now add, or so-called push, this method onto the stack of calls. And similarly as well, if you then step inside another method, inside that method, again, that new method will then be pushed onto this stack. So method calls in Java, I don't know if you know about this, but it's basically, you have this notion of a stack. And if you can think of like a stack of plates in a restaurant. So the first method call you make is like putting a plate down onto the work surface or whatever. Then when you make a second call, so when you make a call within that method, it's like pushing down a second plate on top of the first plate. Now the first plate is the original method. The second plate is the new method, okay? So now when we're in this new method, again, we might step into another method, and again, we put another plate down, and this is the third method. And this notion of putting things down on top of each other, and then removing things after the fact, so what I didn't mention just now, is the fact that when we return out of the innermost method, right, what actually happens is the method is what's known as popped off of this stack, which means that the third plate, which was the topmost plate, is now taken off. Now we're back inside the kind of middle method, if you like. And then as we return from that middle method, the second plate, which was now representing that middle method, is now taken off. And now we just have this one plate left, which is the original method, the top level method, the outermost method, the original method that we were in before. This might seem a bit abstract, but basically Java has to be able to keep track of the methods that you invoke and the state of what's inside those methods. So the state of the variables that are associated with that particular so-called stack frame. And it does this by a thing, a data structure, known as a stack, which is also known as a file, a first in, last out data structure. In other words, the first thing that you put in, because it's now at the bottom of the stack as plates are getting on top of it each time, as more plates are being added, necessarily you have to move off those plates off of the top before you can get to that original entry. So that's why it's the last one out. So it's the first one in, the last one out. So philo, first in, last out. Now, that was a bit of a long explanation. I apologize for that, but if you have this notion inside your head of the stack that you would see in an IDE when you're debugging through code, and you're in this third most method, so this deepest, most nested method call, right? Then you have 3 methods on the stack in the debugger window. So you can imagine method 1 is at the bottom, method 2, which is the middle method, is above that, and the one at the very top is like method 3, which is the innermost method. Now this is known as a call stack, and it's basically the stack of methods, or the stack of method calls, which got you to that particular position in that method. And this so-called call stack, when we're looking at it from a structural point of view in an IDE, is known as a call hierarchy. So in short, a call hierarchy is where method A calls method B, which calls method C. That can be one call hierarchy. It could be where method D calls method E, calls method A, which could be a different call hierarchy, or whatever. And what an IDE will allow you to do is to right-click on a method and say show call hierarchy. And then what you'll find in IntelliJ IDEA, for example, is that on the right-hand side of the IDE, you'll have kind of a tree view of all of the possible call stacks which make up that call hierarchy. In other words, it will show you from that specific method all of the different routes throughout the entire code base that could possibly get you to where you are now. And those in turn, by the way, would correspond with the stacks that you see when you're stepping through the debugger. Okay, this is massively abstract. It really requires more of a visual kind of explanation. If you're following this now, by the way, very well done, because this is like pretty abstract stuff. You really have to see it in an IDE to fully comprehend it. But the big takeaway here is the fact that, an IDE will give you this notion of being able to look at the code from the perspective of show me the call hierarchies. And that's great because you can start to then visualize the flow of execution throughout the program. Now, in addition to call hierarchies, that's the complex bit over with now. Okay, we'll come back down to earth now. In addition to call hierarchies, you also have class hierarchies. So this is more on the OO side of things, the object-oriented side of things. But if you have a particular class, for example, you can right-click and show class hierarchies, and that will show you all subclasses of that particular class. And similarly, you can go the other way as well. You can show all superclasses. So this can then enable you to jump to different implementations, which can be useful as well. You can also see which methods throw which type of exceptions and that kind of stuff. But the key point here is that at this third level, kind of like IDE ninja coding kind of level, I guess, we're starting to use these tools for analysis. And actually, the sooner you can get to use these tools, even if you're a junior developer, if you can start to have a play around with these things, look at call hierarchies, class hierarchies and that kind of stuff, get into the more advanced side and join the dots to, for example, what's happening in a debugger, you'll soon find that you start to comprehend Java and software engineering at a much deeper level than you expected you would do. And you'll soon be seen then as a much more senior developer. Now, in addition to this analysis of the code, which is pretty much the code as it is now, we also have the analysis of the code as it was in the past, or the history. So when you start to be on a professional Java software engineering project, all of the code that you write and that your team members write is committed into a repository. Some kind of version control system like Git is the most popular one now. Subversion was a popular one from a few years ago. There were other version control systems, CVS, Visual Source Safe, ClearCase, PBCS Dimensions, the list goes on. But the main one now is Git. And so what an IDE also gives you the ability to analyze is the actual history of the code that you're looking at, which can be useful because then you can see who made which changes to which files, which classes, which lines were affected. You can then click on that particular line that was affected and see other affected files, so other changes that were also made in that specific commit, that kind of stuff. And that's very good for being able to track down what happened. For example, if there's some kind of issue and somebody was working on some particular area of that system, you could go through the Git history, maybe do some comparisons between different versions, comparison between the develop branch, which is the most stable branch perhaps, and the feature branch that you're currently working on, and see what's happening there and everything. Now, if you try doing this in a text editor or doing it via the command line, it's massively tedious, it's difficult to comprehend, but once again, the IDE, it steps up and it gives you these things completely out of the box, these tools, this rich tool set to enable you to, again, work at a much higher level and not have to be bogged down in the minutiae of, the tooling, the command line tools, the syntax, all that kind of stuff. No, we can just focus on what our job is, which is to just write great Java code in the IDE and produce what we need to produce for the project without having to get bogged down with all of these lower level things, which the IDE effectively allows us to use really easily, really effectively, putting it out for us there on the table on a silver platter. So overall, IDEs give you an excellent developer experience from conception of an idea to fleshing out some basic code from scratch through to actually maintaining a full-on legacy system, everything along the way. And it gives you the exact support that you need, whatever level you're at. So if you're a junior developer or you're just getting started, or through to a complete senior developer, software engineer. It gives you all of the support you need all the way through. So it's an absolute powerhouse of tools. I encourage you to dig in and find out more today about what IDEs can do for you. And that about wraps it up now for our series on getting to know the IDE better. So hopefully that was useful for you and you've got a better appreciation now for our biggest and best tool, the IDE. With that being said, all that's left to say is I wish you a great week ahead, happy coding, and until next time, take care. Bye.